Hello, boys and girls, ladies and gentlemen. Today, Mr. Muscarella is going to take you on a journey where we're going to learn about increasing and decreasing functions and the first derivative test. In this lesson, you're going to see how to use the first derivative test to determine where functions are increasing and decreasing. And secondly, you're going to learn how to use your graphing calculator to analyze a function and the derivative of this function. Two very important skills that you will use throughout calculus. So make sure you have your graphing calculator ready, and let's go ahead and begin. Now, a lot of times you'll see directions like this. Find intervals where the function is increasing, decreasing, and determine any relative extrema. So here's our function as polynomial, and we're going to first take the derivative. Now when we do that, the first derivative, remember, we're just going to use the power rule because this is a polynomial. We'll end up with our derivative, f prime of x equals negative 4x squared minus 4x plus 24. What we're going to do next is set our derivative equal to 0. And, because we've got mad math skills, we're also going to factor out a negative 4. When we do that, we're going to go ahead and factor our polynomial into 0 equals negative 4 times x plus 3, and then the quantity x minus 2. What we're going to do after this piece, once we get it factored, you're going to go ahead and set each one of those factors equal to 0, and then solve to determine the critical numbers. So the very first thing we did was find the first derivative, set it equal to 0, and then determine the critical numbers for our derivative. Now the second thing we're going to do after we figure out our critical numbers, we're going to make, a lot of times it's called a wiggle graph or a line graph. And what we're going to do is take those two critical numbers that we got, negative 3 and 2, and we're going to plot them on the number line. And what we do is we're going to then test some points. And we're going to test one point before negative 3. We're going to test another value between negative 3 and 2, and we're going to test another number after 2. Now, when you pick your numbers, you can pick any numbers you want, but before negative 3, I'm just going to simply choose negative 4. And what we're going to do is we're going to evaluate that in the derivative. Now, factored, and this is what's kind of nice. If you plug in negative 4, anywhere there's an x, you have negative 4 plus 3, and then negative 4 minus 2. When you simplify that, all you're going to do is get a value of negative 24, because that's a little bit easier to do mentally than if you plugged it in to the derivative before you factored it. Now, that value of negative 24, that's going to tell me two things. One, it's telling me my derivative is negative. Now, a negative derivative means that my function is going to be decreasing. It's going to be moving in a downward direction like this. Now, the next number I'm going to pick is going to be somewhere between a negative 3 and 2. And anytime I'm given the opportunity, I like to use the number 0, because that's really easy to do. And sometimes what I'll do with 0 is I'll just look at the derivative before we factored it, because the only thing that's going to be left is just going to be any constant. And in this case, that constant is 24. Now, 24 is positive, which means my function is going to be increasing or moving in an upwards direction. Lastly, I've got to pick one other value, and that's on the right-hand side of 2, so I'm going to go ahead and choose 3. Now, when I plug 3 in, again, I'm going to use the factored form, so I'm going to have negative 4 times 3 plus 3, which gives me 6, and then I'll have 3 minus 2, which gives me 1. So when I multiply those together, negative 4 times 6 times 1, I'm going to end up with a value of negative 24. So I get another negative 24, but I don't really care so much about the number as I do the sign. And the sign of negative 24 is negative, which means my function is decreasing. It's moving in a downward direction. all of this did, this little sign chart, that helped me determine the intervals where the function's increasing and decreasing. But I need to do a little bit more than that. I also have to figure out some max and min stuff. So now what I'm going to do is I'm going to evaluate the critical points, my two x values that I came up with in the original function, to figure out if I've got a max or a min. So now when I plug in -3 to my original function, I end up with a value of -51. And when I plug in 2 to my original function, I end up with this nice fraction of 97/3. Now this is where the analysis comes in. I've got to look at these two values, -51 and 97/3, and determine which one is bigger than the other one. Well, I'm sure that's easy for you to do because 97/3 is positive, which means our bigger value is going to be our max and our smaller y value is going to be our min. So that wasn't so bad. All you have to do is evaluate the critical numbers into your original function and then analyze what your biggest number is and what your smallest number is when you plug those values in. Your biggest number will be your max and your smallest number will be your min. That's it. Pretty straightforward. Now we're going to summarize all of this nicely, neatly, and with correct mathematical notation. So here are all 5 conclusions that we came up with from using the first derivative test. Make sure that you get all 5 of these down and that you word them correctly and use correct notation, because those are some small detail kinds of things that are going to be very important as you go throughout the course. All right, so here's how I want you to get your calculator set up. This is going to take you a few seconds. Put your original function in y1, your derivative in y2, and get your windows set up just the same way that I do. Once you've got all of that set, go ahead and hit graph. All right, how'd we do? Hopefully our pictures match. Now what I want you to notice here, and this is a critical piece when you start doing graphical analysis of your function and its first derivative, is take a look at where the zeros of your derivative are. So we've got 1 here, one of our critical numbers was -3, and our other critical number was +2. Where those two values are, and look what's above or below them. We've got a minimum down here at x equals -3, and we've got a maximum over here at x equals 2. That's going to be a critical piece to analyze as you take a look at a function, at a picture of a function and its first derivative. So that's going to be something you'll see throughout the course, and you need to be able to analyze graphs to determine where a function is and where its derivative is, which one is which. All right, so that's just something else I wanted to throw at you guys to make sure that you're understanding the graphical analysis in addition to the numerical and analytical pieces of using the first derivative test. All right, that's it for today, boys and girls, ladies and gentlemen. Thank you for watching, and I will catch up with you again later. Peace out.